Someone asked for me to start teaching calculus. Oh, here's a video. So, of late, mathematics, both paper 1 and paper 2, has been including calculus, which before was not included in the past papers. So, as it is right now, you are bound to find integration and differentiation in your papers. Okay, so what is calculus all about? Calculus has two major components. There's integration and then there's differentiation. What are these two? So, integration means to build up. This is the best way you can look at it. So imagine you have a foundation, you want to start building a house, you start putting bricks together and whatnot. There's a structure that is being built up. So to integrate, just look at it as to build up. Then to differentiate, differentiation. This one, you can look at it as to tear down. So these two are the total opposites of each other. That's why, using your thinking ability, if you understand how to integrate, you can also differentiate. So what are we building up? What are we tearing down? These are the powers of the variable. Most likely, you are given x. This is integration. We'll get there. So let's say for integration, the power of x, let's say it's 3. When you are integrating, the power of x will be increasing. Maybe let me say plus 3. So when you integrate this, the power of x is bound to increase. Then differentiation, if you have the same thing, x to the power 3, the power of x will be reducing. I don't mean it to become negative 3, I'm saying it will be reducing, 3 going down. So what we integrate or what we build up are the variables. So the x for integration, its power will be increasing, plus 3, meaning it will tend to 4, 5, 6, and whatnot. Then for differentiation, the power of x will be reducing. From the original 3, it will be going down. So let's get into the integration procedure now. So how do you integrate? First thing first, the integration, whatever, looks like this. Most papers you're going to see something that looks like this. So when you see this integral symbol, my brother used to refer to it as akasoka. So if you are able to solve this, then tuwai by akasoka. So this is how integration looks like. So what are we actually doing here? There is a procedure that you're supposed to follow. And this procedure looks like this. If you have the integral symbol like this, and then you have n representing a number, any number, x representing a variable, and then up here you have a representing a power, like that, dx. For us to be able to integrate, the n comes as it is, then the x comes exactly as it is. The power of x will be integrated or will be raised up, will be built up by adding 1. So to the power, these bases, the number, the variable, come as they are, but the power of x or the variable will be increased by adding 1. Then you take this same thing, this power, you divide everything by the power. So this is the procedure. Put simply, the n comes as it is, the x as it is, the power of x or any variable, sometimes it can be y, you have to add a 1, then divide everything by the power of x. Let's see if we can do that here. So given this example, what we are going to do here is integrating this. 2 is the n, so it will come as it is. X is the x as it is here. Then this 2 is represented by a, the power of x, so I'll do 2 plus 1. Then divide everything by 2 plus 1. Now go to this one. X, so there's no n, there's no number. So we just ignore it. We just go to x, then the power. Any number that is just without the power, without itself, is to the power 1. So for example, if you see a 9 like this, it's as good as 9 to the power 1. So it's like this x is to the power 1 already. So it's like 1. Now we raise it by another 1. Then we divide everything by the new power, which is 1 plus 1. And this therefore will be 2x, 2 plus 1 will give 3. Then at the bottom, 2 plus 1, 3. Plus this side, x, 1 plus 1, this will be 2. 1 plus 1, this will be 2. And just like this, we have integrated. And if you can see here, x was to the power 2, here it's to the power 3. Its power has been increased, built up, to the power 1, to the power 2. Example 2. So for this one, x will come as it is, its power 4 plus 1, then we divide by the power 4 plus 1, then minus 2 will come as it is, x will come as it is, its power 3 plus 1, then divide by the power 3 plus 1, then the other one is x to the power 2 plus 1, divide by 2 plus 1, close it off like that. So this will be x. By the way, these braces I'm putting there, sometimes you don't need to put them. Even if you don't put them, for now it's fine. We are not yet dealing with limits. So even if you don't put them, it's fine, but I'm just used to doing this. So x to the power 4 plus 1, this will be 5. 4 plus 1, 5 minus, this is 2x. Power will be 4 there, 2 plus 1, 4 there, plus, this is x to the power 3, then at the bottom, 2 plus 1 is 3. And just like that, you have integrated. The general idea here is the n comes as it is. The number, x, the variable, comes as it is. Then the power, we add 1. Like that. Then we divide everything by the new power. This is the main concept of integration. Let's go to differentiation. Okay, so I'm supposed to get rid of this, but you remember I mentioned that if you know how to integrate, you also know how to differentiate, because it's the total opposite. So let's see if we can use the integration procedure to come up with a differentiation procedure. And this is useful because, for me, there were times I could forget how to differentiate. Now, since I knew how to integrate, I could work out the differentiation procedure from this one, because it's just the opposite. So, for differentiation, instead of putting this integral sign, akafoka, they do this. They say dy dx. So finding dy dx of n x to the power n. How do you find dy dx of this? Again, the n comes as it is, unaffected. The x comes as it is, unaffected. Then, here, the a up there. Here we were dividing, so here we are going to do what? Multiply. Here, we were using the new power. After we add 1, then we divide. Here we use the odd power. So we put the a, we multiply by the a. Then, for the power of x, here we were adding, here we are going to do what? Subtract. So, long story short, we change the power, yes. Here we add, here we subtract. Here we divide by the new power, here we multiply by the old power. We are just doing the opposite. So let's see if we can use this procedure there. Mind you, these, if you pay attention, these are the answers from the integrals that we found. Now, if we differentiate this successfully, it will give us the questions we started with under integration because they are the opposite of each other. It's more like respiration and photosynthesis. So for this one, what am I going to do? Finding dy dx of this, I'll say dy dx of this 2x to the power 3 over 3 plus x squared over 2. So for this one, what I'm going to do is, as usual, I'm going to get the 2 as it is, the x as it is. Then for the power of x, I'm going to do 3 minus 1. Then the a, I'm going to, oh by the way, it's supposed to be a 3 down here because it's 2 over 3. So n is 2 over 3 here, x as it is. Then for the power, subtract 1. Then we are going to multiply by the odd power, which is 3, plus here the x, or maybe I'll start with the n. The n is 1 over 2, or just over 2. Then the x as it is. Then the power 2 minus 1. Then I'm going to multiply everything by the odd power, which is 2. Now, looking at this will cancel with this. So I'm going to remain with 2x to the power 3x, then 3 minus 1 is 2, plus this will cancel with this, and this is x, 2 minus 1 is just 1. If you go back, this is what I had in the first exercise. Then going to this, finding dy dx of x to the power 5 over 5 minus 2x to the power 4 over 4 plus x to the power 3 over 3. So for this situation, what am I going to do? Starting with the first part, so this is just x over 5 as it is, then 5 minus 1, then multiplying everything by the odd power, minus, which is 5 there, 2x over 4. Then x is to the power 4 minus 1, multiply everything by the odd power, which is 4, then plus there, I have x to the power 3 minus 1, then it's supposed to be over 3, multiplied by the odd power, which is 3. I with 5, which is x to the power 5 minus 1 is 4, minus this is going to be 4 to x, then 4 minus 1 is 3, plus this is going to be with 3 x to the power 2. If you check, this is what I integrated in the first example, and this is also what I integrated for the first example. So if you see, differentiation and integration are the opposite of each other. Maybe giving you a simple question other than this, so you can easily see that they are the opposite of each other. So let's say if I have 2 to the power 6, this, differentiating it, what am I going to do to differentiate? 2 as it is, x as it is, for the power I will do 6 minus 1, which is going to be 5. Then I multiply everything by the odd power, which is 6. 6 times 2, 12, x to the power 5. This is differentiated. Let's get the answer and integrate it. So the answer, 12, x to the power 5. Integrating this. So here we found dy dx of this. Integrating this answer should give us 2x to the power 6. Let me show you. So this will be the 12 as it is, the x as it is. Then for the 5, we add 1. So 5 plus 1 will be 6. Dividing everything by the new power, 6. This is going to give us this 1, this 2. 2x to the power 6. So if you see, differentiating, differentiating something and then integrating it will get us back to the original question. So this, after differentiating, gave us this. This same answer, after we integrated it, gave us back the original answer. So now we can go to the actual exam question. Okay, before we can go to the actual exam questions, let's see if we can talk about limits. I forgot to talk about limits. So with integration, there are times when they are going to involve limits, which is most of the time. So what are limits? They might give you a question that looks like this. Integrating 2x to the power 3 plus x, let's say, to the power 4, as an example, dx. Now, instead of just ending there, here they will say 1, and then down here they might say maybe let's say 2 here, and then here they say 1. How do you deal with these numbers? First thing first, forget about these numbers. Just integrate them all. So let's integrate this over here. Integrating this is 2x power 3 plus x to the power 4. So now integrating this, we are going to have this 2 as it is, x as it is, then the power of 3. If we add 1, it will become 4. Dividing by the new power, we have that, plus x as it is, then the new power will become 5, dividing by the new power. There we have integrated, but we can simplify further. 2 into this, 2 into this, 1. So this is therefore going to be x to the power 4 over 2 plus x to the power 5 over 5. Now, just like this we are done. Now we have these limits. So sometimes it's wise to do this and then put the 2 up there, 1 there, 2 up there, 1 there. Showing you that the limits are still involved. Now, how do we use them? The limits work like this. Let me see. Didn't plan this well, but I think we can deal with it here because the limits. Okay, let me just take the answer. X to the power 4 over 2 plus x to the power 5 over 5. This is still 1. Okay, so this is the answer that we found there. Now let's see if we can solve with the limits. How do we solve this? So you do this, simply do this, and it's very easy. X to the power 4 over 2 plus x to the power 5 over 5. Then this is for the first limit, the one on top, 2, then minus, you get the same thing again, x to the power 4 over 2 plus x to the power 5 over 5. And then this is the limit of 1. It's the same thing. We write it here, we put 2. The first limit minus, same thing, then there you put the second limit, the one down here. And then you just substitute those numbers into the equations. So this is going to be 2 to the power 4 over 2 plus 2 to the power 5 over 5 minus, here I'm going to have 1 to the power 4 over 2 plus 1 to the power 5 over 5. Then here, 2 to the power 4 is going to give us 16 over 2 plus 2 to the power 5 is going to give us 32 over 5 minus, then here, this will just be 1 over 2 plus this will also be 1 over 5. And then you just work it out from here. So here, 16 plus this, what am I going to have? 16 over 2, which is going to be 8 plus, then there's 2 over 5. Then this part is straightforward. Or maybe we can just simplify it here instead of doing this. Here is straightforward. We can just reduce it there and then making this an 8 and this a 1. And then here we can do this. Let's see if we can use butterfly method. 1 times 5 is 5, and 5 times this is 40. Plus 1 times that is 32, minus this times this is 10, that times that is 5, that times that is 2. Then here I have 40 plus that is going to be 272 over 5 minus, then here this plus this is going to give me 7 over 10. Pretty sure from there you can solve it. So the idea with limits is that you just get these very numbers, you substitute them into the final answer, the one that you have integrated. After integrating, then you fuse in those numbers. And then after you fuse in them, substitute them in, and then you can work out the final answer. From here, you can solve it. It's very easy. Or maybe let's just do it together. So even here, using the same butterfly method, 5 times 10 is 50. Then 10 times this, 720, minus 5 times this, 35. Now 720, this is going to be 1, this is going to be 10, so this will be 5, this is going to be 68, 69, 71, 68. So this is going to be 685 over 50. If you want, you can go ahead and make that into a mixed number. So this is all about dealing with limits. Now let's solve exam question. Okay, so this is how questions are going to look in the exam. So this is 2025 paper 1 GCE, 3x to the power 3 plus 4x, find the integral. They won't say differentiate. As long as you see the snake, you should know that this is integration. So integrating this time around, I'm not going to be slow. I'm taking it you have enough knowledge to follow me with what is going on. So the first one, maybe I don't even need the braces. I can just go ahead for this one. 3 as it is, x as it is, the power, I'm going to add 1. So 3 will become 4, and then I divide it by the new power. Plus this part, 4 as it is, x as it is. If a number letter is just by itself, the index, the power, the exponent is 1. So it's like there's a 1 there, then plus 1 is going to be 2, dividing by the new power, 2. Then from here, there's nothing we can do here. No simplification required. This is as it's supposed to be, plus 2 into this 1, 2 into this 2. This will be 2x to the power 2. Done. Now, there aren't many differentiation questions, so whichever I integrate, I'm also going to differentiate so that you can practice it. So we will differentiate the final answer. We should get the question. So differentiating here, so this is going to be 3x to the power 4 over 4 plus 2x to the power 2. So differentiating this, we say dy dx of this. Finding dy dx, what do we do? 3 as it is, x as it is, the 4 at the bottom as it is. The only thing that changes is the power. For the power, we are going to subtract by 1. So 4 minus 1 is 3. Then we are going to multiply by the odd power, which is 4 as it is, plus 2x. Here we subtract by 1, it's going to be 1. Then we multiply by the odd power, which is 2. Then here this will cancel with this. I will have 3x to the power 3 plus here 2 times this, I have 4x. That. So if you find the final answer under integration, differentiating it and getting the original question as your answer under differentiation will show you that what you're doing is correct. Let's go to number 2. Okay, 2023, even this one, no limits whatsoever. So we integrate, then differentiate that side. So integrating this, no need for the braces. So just starting with this x as it is, the 3, we add 1, 3 plus 1 will give us 4, then divide by the new power, 4 plus 2 as it is, x as it is, it's just alone. So that means the power is 1. So adding 1, that will give us 2, divided by new power, 2. Then this 3, that 3 has an invisible x, because it's 3x. If it's just like that, it's to the power 1. If it's not there, then it's x to the power 0. Any number to the power 0 is what? 1. 1 and 3 times that. That's how come the 3 is alone there. So there is an x there to the power 0. Now, that power 0, if we add 1, it's going to give us 3x power 1 divided by 1, like that. Then here, you can't change anything. Here, this with this, x squared, and this, done. Now let's see if we can differentiate it here to prove our answer. So we're getting this, differentiating, this is dy dx of x to the power 4 over 4 plus x squared plus 3x, like that. So for this one, again, we are going to just go straight to the point. So x as it is, the 4 at the bottom as it is, the power, we subtract 1, becomes 3. Then we multiply by the odd power, 4, plus this x as it is, the power we subtract by 1 becomes 1. Then we multiply by the odd power, which is 2, plus here 3 as it is, x as it is, the power there is 1. If I subtract by 1, this is going to be the power 0. Then we multiply by the odd power, which is 1. So this will cancel with this, x to the power 3, plus here this times this, 2x, then this plus 3 as it is. Any number to the power 0 is 1 times 1. This is x to the power 3 plus 2x plus 3 times 1 times 1, 3. So this is integration, differentiation. As you can see, this is exactly that. Example 3. Page 25. Now this one has limits 1 and negative 3. So first of all, I'm going to integrate it, differentiate it, remove the differentiation, then finish off with the limits, because I want you to practice differentiation as well. So this one, integrating it, 6 as it is, x as it is, the 2 plus 1 become 3 over the new power, minus, this is 5x, that will be 2 over 2 plus 2x over 1. Then here, this will be 2x to the power 3 minus 5x squared over 2, this doesn't change, and then plus 2x. Let's differentiate. So finding dy dx of 2x to the power 3 minus 5x squared over 2 plus 2x. The first part, 2 as it is, x to the power, the power will subtract 1, so it becomes 2 times the odd power, which is 3, minus, this is 5 over 2, x to the power, this is 2, and we subtract 1, it's going to become to the power 1, multiplied by the odd power, 2, then plus, this is 2x, the power is 1. So we subtract 1, it's going to be 0, multiplied by the odd power, which is 1, so this is going to give us this times this, 6x to the power 2, minus this times this, is going to give me 10x over 2 plus 2x to the power 0 is 1, so it's going to be 1 times 1. So this is 6x squared minus 10 divided by this 5x plus 2 times 1 times 1, 2. 6x squared minus 5x plus 2x. So we have differentiated it and g is the same. Now let's see if we can use the limits. Someone to please buy me a duster. Okay, so after we have done this, coming there, you remember these? I am used to putting them there because they help me know or have somewhere to put the limits. So 1 up there, minus 3 up there, 1 up there, minus 3 up there. So coming here, this is 2x to the power 3 minus 5x squared over 2 plus 2x. Now this is for the first limit, 1 minus, second part is 2x to the power 3 minus 5x squared over 2 plus x minus 3. So we are just going to infuse those numbers in there and see how it works out. So here, this is going to be, when I put the 1 here, this is 2, 1 to the power 3 minus 5, 1 to the power 2 over 2 plus 2, 1 over the top minus, this is going to be 2 minus 3 to the power 3 minus 5 minus 3 to the power 2 over 2 plus 2 minus 3, and then close it up like that. Then from there, here, let's not waste time with this. 1 to the power 3 is still 1 times 2. So this is just going to be, this whole thing is just 2 minus 1 to the power 2 is just 1 times 5 is just 5. So it's going to be 5 over 2. Then this part, 2 times 1 is just 2 minus this part, 3. It's like we have it like this. So this is negative times negative, positive times negative, which is minus 3 times 3, 9 times 3, 27. So this whole part is going to give us a 27, a minus 27. Then here, this is negative 3 times negative 3, which is going to give us a positive 9. Then times this, so that's going to be a minus, times 5, it's going to be 45, everything over 2. Then this will be minus 2 times this, 6. And then from here, you just work it out. So what are we going to do here? Simply over 1, over 1, over 1, over 1. Then, using our butterfly method, 1 times 2 times 1 is 2. So this number can all go into that one. So then from here, or maybe to help you see this easily, you can just do this. Take it easy here. So this is just a 2. This is just a 2. 2 plus this 2 will be 4 minus 5 over 2. Then that side, ignore this, ignore that. Forget about the fraction. Minus 27 minus 6. It's like we are putting 6 on 27 only in the negative direction. So this is 27, 28, 29, 30, 31, 32, 33. So this will be minus 33 minus 45 over 2. Now here we can go ahead and use the butterfly method. So now that it's easier, so this times this, 2. This times this, 8. That times that, 5. Now you have that. And then here, this time this is 2, this time this is minus 6, then this time this is minus 45. He finished it from there, amount of space. Okay, let's solve this last example. So let's again start with integrating it. So 6 as it is, x as it is, the 5 we add 1 becomes 6, then we divide by the new power, which is 6. Then minus x as it is, then the 4 becomes 5, dividing by the new power, 5, plus 3 as it is, x as it is, the power, we add 1, becomes 3, dividing by the new power, becomes 3, then minus 1. It's like 1 is with x to the power 0. So now when I add 1 here, it's going to be 1x, but we don't say 1x in math, so we just say x. So this part will just become an x divided by the new power 1. Then reconciling them, this with this, minus x to the power 5 over 5 plus this with this, x to the power 3 minus x. Done. Now, getting to this part, differentiating them so that people know how to differentiate. So this finding dy dx of 6x minus x to the power 5 over 5 plus x to the power 3 minus x. So here, start with the first part. So the first part, x as it is, then the 6 minus 1 will be 5. Then multiplying everything by the new power, sorry, the odd power, which is 6, then minus. This is x to the power 5 over 5 as it is, but this power is supposed to be subtracted by 1, so it becomes 4. Multiply everything by the odd power, 5, plus this is x to the power 3. We subtract 1 becomes 2, multiply everything by the odd power, 3. And this is minus x. So for this one, this is x to the power 1. If we subtract 1, it will become what? X to the power 0, multiplying everything by the odd power 1. So this is going to be x times this will be 6x to the power 5 minus this goes with that, x to the power 4 plus this times this, 3x to the power 2, then there minus any number to the power 0 is 1 and 1. So this is going to be 6x to the power 5 minus x to the power 4 plus 3x to the power 2 minus 1 times 1 is 1. 6x to the power 5 minus x to the power 4, 3x squared minus 1. Then let's see if we can use limits. Okay, so for this one I'm going to be quick. So we're going to get a little bit bigger. 6 x to the power 5 over 5 plus x to the power 3 minus x. So this one is going to be for 2 minus same thing, x 5 over 5 x to the power 3 minus x. This one is going to be for negative 1. So this one, let's be quick. If we put 2 here, let's just go with it together. So this will be 2 to the power 6. This will be 2 to the power 5 over 5 plus to the power 2 over 3 minus 2. This will be minus 1 to the power 6 minus 1 to the power 5 over 5 plus minus 1 to the power 3 minus 1 like that. So here, 2 to the power 6 64. Then 2 to the power 5, 32 over 5. 2 to the power 3, 8 minus 2. Then this part, negative 1 to the power 6. To be like negative 1 times negative 1 times negative 1 times negative 1. 6 times is just going to give us 1 minus. Then this negative 1 times itself 5 times, that's going to give us a negative 1. Negative 1 times this is going to be plus 1 over 5. Then this will be minus 1. That will be plus 1. I think from there we can just start killing things off. So here, this is 64 minus, or maybe, yeah, let's do what we did in the last example. So this is 64 plus 8. 64 plus 8 is going to give us 72 minus 2 will give us a 70 minus 32 over 5. So I've just done 64 minus 2 will give us 62 plus 8, 70. Then we have this fraction there. We can work it out there. And here minus, here positive 1 and negative 1, they just die together. Then here I have 1 plus 1 over 5. And I do this, and do this. You can finish it from there. It's very easy from there. So this is integration and differentiation under calculus. Mind you, I always teach the things that are relevant, things that you're going to find in the exam.